Hey, good morning. Do you want to take a guess at what it is I want to use this video to talk about? Ambiguity. Yep. I would like to talk about how to use confusion to help kids learn. In fact, I believe that if students aren't ever confused, they don't actually ever learn. There's some pretty strong evidence that this is the case. A lot of that research is done, well, not in a high school class setting, but, well, more with students learning independently. You see, I've mentioned it before, but one of the sources that I found most powerful in my development as a teacher was Sugata Mitra, and he talked extensively about how students have to learn together. Not just that they have to learn together, but that's the nature of learning. Kids learn together. And to that point, as people, we don't learn in isolation. There are very, very few of us that do. And those of us that do, we usually end up in the history books. So, probably not anybody watching this. Certainly not me. I don't have the intellect or, well, the perspective and the self-awareness to know when I'm really off base, when I'm wrong, and I don't really know it. Neither do you. We trick ourselves all the time. I took a psychology class in college, and part of the class, was conducting an experiment on the students of the class, and, well, of course, we didn't know. The way the experiment worked is we were asked a question that we were almost guaranteed to get wrong, but we didn't know the importance of this question. And then, shortly after the question, we were told that everybody gets it wrong. We were told the right answer, and then we were asked if we had the right answer or the wrong answer. Now, everybody gets the question wrong, and yet almost everybody remembers that they said the right answer when in fact they did not. I did the same thing. I was blown away. Had I not had physical record in my own writing that I in fact answered wrong, I wouldn't have believed it. So we need the feedback and the perspective of our peers that are kind of struggling with the same things. They question us, we question them, and I might have half of the idea that's required for real understanding, and the other student might have the other. Together, we put it together, and we understand. That's kind of how it works. So, the other piece of the puzzle, though, is the ambiguity. If you, as the teacher, are just up there just spelling facts, you're just the authority, well, they're not going to question you, even if you should be questioned. For example, if two kids are talking about a problem they're working on and they want to know who's right, they ask you for confirmation, who's right. If you say one of them's right, they're done thinking. They're off the hook. They're now going to be, bragging about being right. Not really understanding at all. Because if you don't know why you're right, you don't really know. It's more than just having a right answer. You understand? It is definitely more than having a right answer, and I guess that's kind of the key behind the idea that if you just give them the information, well, that's insufficient. It takes much, much more. So anyway, I was bringing all this up because I'm teaching yesterday I was teaching a rather boring lesson in geometry, just about the way geometry is written. So like, how do you write the name of an angle from a diagram? Or if something's named, like in the description, and you have a diagram, how do you know which part of the diagram they're talking about? Not very exciting stuff. But I challenged myself, not bragging, I'm just trying to give an example of what I think works. I challenged myself to, come up with questions and explore those questions that expose misconceptions of students. Because, even if you think they don't know anything about your subject, they do. In fact, they have to. Otherwise, it would make absolutely no sense to them whatsoever. If a student were to sit down in your class and be completely void of any background information, it wouldn't work out. So anyway, those are the things I wanted to share with you today. take it upon yourself to play with a little ambiguity. Don't be afraid to let the students be confused. Talk to them, question them. Don't say what's right or wrong when the students are sharing out. Explore those things. Ask students if they understand, not if they agree or not, and ask if they can explain further, and really explore the misconceptions. And once they're all the way explored and we're at like a pinnacle of confusion, then you can discuss, well, what is right? And hopefully there's a student in your classroom who knows what's right and why. If not, it's still a good opportunity. It still will be effective if you end up having to tell them, but if it comes from a student, it's even better. So anyway, take it upon yourself, be brave, play with that confusion. It will be successful if the students understand why you're doing it, and they will be more engaged, they will learn, and, well, everybody will have greater success. And that's why I'm sharing these videos anyway. So, last thing, I don't know if you know, I've been saying it a lot lately, I'm on a mission. The issue I wish to resolve or address or help with is that students are graduating from high school and having to take a lot of remedial math classes in college. Or they're not going to college, or they're changing their dream jobs because they find out that, well, the program they need has too much math, or maybe the math is too difficult. I don't think that is quite right. I don't think that's the way it should be. It doesn't need to be that way. And it's not that math is too difficult for students, it's that we're teaching it wrong. The materials are wrong. We are in the midst of a paradigm shift, especially in secondary mathematics education. And what the industry is doing is they are doubling down on the old failed methods. There's very little good resource out there. So what I'm doing is I'm trying to produce quality resources that, well, number one, the work that I create for students to do is designed so that it's approachable, it's understandable, but it should expose misconceptions that, well, then it's your job when you review that work to discuss those misconceptions and replace them with correct understanding. I'm also doing a lot of work on, well, that you can use to, well, dispense information in a quality manner in class, and, well, trying to do all of everything that's normally taught in high school from the beginning of their freshman year to the end of the senior year. It's a huge undertaking, and I could use your help. There are two ways. It costs you absolutely nothing. Number one, I'm trying to gain traction. This is a brand new endeavor right now, so you can like and share on social media, share it with colleagues. Help get the word out there as to what I'm doing if you think this is of quality and it's a project that's worth merit. The other thing you can do, you can leave me comments. I need your feedback. I need some direction. I've got ideas, but again, no man is an island, right? So anyway, that's it. Now, if you visit my website, beardedmathman.com, and you click on the support button, anything you buy through Amazon on my site doesn't cost you anything extra over what you would pay if you just went to Amazon.com directly. But I get a little tiny portion, and every little bit I use goes right back into the program because, well, this is a big undertaking. Anyway, I'd like to thank you once again for your time. I hope this has been of use. Let me know in the comments what you think, and until next time, thank you for watching.